I'll wait for a few minutes, maybe 1 or 2 more minutes, so that other can join. Can you see the screen?
Yes, sir.
Okay, thanks. Okay, let's start. Last lecture, it was almost about 2 weeks ago. Sorry that I got into sick and couldn't take up classes. So we'll resume from where we left. Last lecture, we started with HTTP protocol. We looked at HTTP messages, format, set two kind of messages, request and response, and we looked at the message structure, which is basically request message is request line followed by the headers, and same was true for response message. First line was the status line, and then HTTP headers, then a blank line, and then the content. So what a browser actually displays is the content after the headers. And that is what we studied last time. So just review the headers, what we have, and then we look at today's topic called persistent connections. So we've seen headers belong to general category. That means these headers are used by both client and servers. Like date indicate current time the request is made or response is sent. Connection is the what we study today, which indicates keep alive, on, or persistent connection. My version relates to content type. Then we client specific headers to give a IP address in case of forwarding, proxy forwarding. Host, if a web server software is running multiple websites, then you have to specify which website you are hosting so that you can get the content of the. So same web server can serve multiple websites, and the only way it will know is when client makes a request, it will put in the host the website name, and then web server would serve that. Then you have the user agent. You normally seen that when you access your Facebook or Instagram page through mobile phone versus laptop versus notepad, or let's say iPad or whatever, then you see a different look and feel. So how do these web servers figure out whether you're using a mobile phone or are you using a full desktop? What should screen layout be? And that primarily when a request is made, client always sends a header called user agent. And user agent indicates whether you are a MacBook or a Linux machine or Windows, IE or a Chrome or whatever kind of browser. And that makes a difference. Then the server headers, like which server software, is it Apache, IIS, Nginx, what is the age, how long is valid. And other than that, the important headers are called entity headers, which is basically deals with the content. Like most important header is called content type. Its content type determines how does a browser or the client render the content. If I get a content, let's say which is picture, but the server application send me content type as plain text, then it will try to display picture as a text and what you see is a gibberish. Similarly, if the HTML file but content type happens to be uh, plain text, then it will not format it but display the actual content. Whereas if it's plain HTML, text HTML, then it will format according to HTML. So content type does play an important role. And sometimes when you access a web page, sometimes you see gibberish character, some junk, that basically means the application on the other side is not sending content type properly. Content length is how many bytes so that client can stop looking at content after that. And this caching headers, caching have a performance improvement, and this will study in our next lecture tomorrow. Some of these headers, you can go through the header details. I given you the URL. Just some common, accept what kind of options you accept, character set, languages, ranges, is the content. If it needs authorization, you need username, password, then web server would say authorization needed, or you pass authorization, username, password details. Cache control is for caching, that we'll study tomorrow. Connections is what we study today for persistent connection. Content encoding, whether content is compressed using gzip or some other method. Look at those headers. We talk content length, content type. E tag is again related to caching, so we look at it tomorrow. And then you have more headers. Again, if modified since and none match, and last modified again related to caching. When you study caching tomorrow, we look at these headers. Location is the header if you're accessing a URL and the URL location has changed, then you'll probably see that browser telling you this is the new URL. You can probably access the new URL and there's no content. Most of the time, whenever you access any website, it typically redirects you with the status code 301 or 302 and with HTTPS or the full service. So for example, if you access, let's say Google, wget is a tool you can download and install. So D means dump the headers. Now when I do that, you see response you are getting is it's saying, this is my request line, get HTTP, user agent is wget is software client, host that Google, and connection is key study, and it says status code 301, and header is the location. That means please access new location called http://dev.google.com, and that is what is access. And then browser makes a new request to dev.google.com and makes a new connection, and that's how things continue. So this is the purpose of location. Similarly, there are other headers. You want to get part of the content rather than full content. Let's say content is 10,000 bytes and you want to get content from byte number 7,000 to byte number 8,000, then you can specify range byte 7,000 to 8,000. You will only get those 1,000 bytes and not the other bytes. So to play with it, try it out, understand, and then you understand how the HTTP header would work. Look at it as already said, you can look at the headers, you can use the Chrome developer tool or Firefox developer tools, look at any page and see how the different header works, and understanding of these headers is going to help you. Now let's come to our topic today, which is persistent connections. The main difference between HTTP 1.0 and 1.1 was primarily persistent connection. When you make a HTTP request, browser first sets up a TCP connection, and on the TCP connection, it sends HTTP request and will get the data. Either it can keep the connection TCP connection on, or it can close the connection. In HTTP 1.0, it will close the connection, and that means each web page you access, you set up a new TCP connection. And that is what is called non-persistent HTTP connections. That when you set up a TCP connection, make a request, get the response, connection is closed. And today, if you look at web page, each web page contains number of objects, maybe 50, maybe 100. Try to look at a college website, ksite.edu.in, and see how many embedded URLs it has got. Probably have more than 100 embedded URLs. And so if you were to use non-persistent, every time you have to do TCP connection setup, you'll probably be setting 100 TCP connections, and that will take up time. And that is the reason persistent connections were introduced. That means once you set up a TCP connection, use it as long as you need it, keep using TCP connection for new HTTP requests and access those. As an analogy, you can probably understand the following way. Let's say you want to visit some of a friend in the city. Let's say you need to visit 5 friends in the city. So you call your radio taxi, that's Uber or Ola or whatever it is. And when you call that taxi, you take the taxi from home, go to your friend's house. Now choice is you want to retain the taxi or you can release the taxi. If you release the taxi, you probably less money, and once you're done with a friend, then you again book another Ola. That will take another 10 minutes of wait time, then go to next friend. So each time you move from one friend to another, you book a separate cab, and that would be notion of non-persistent because you are not retaining your radio taxi with you. Whereas if you were to retain the radio taxi with you throughout till you come back home, then you are not spending any time in the waiting because taxi is always there for you. And you certainly get better performance. You will take less time to visit your friends. And that's primarily how the HTTP really works. There's a some URL you need to enter. HTTP client will make a TCP connection on port 80. That's where the web server serves. Web server will accept a TCP connection, and once connection is established, we look at into details of TCP connection setup management when you look at module 2. But for the moment, assume TCP connection is set up, established, and then only browser makes a actual URL request saying get URL so and so with different headers, and web server get that request. It serves that request. It looks at the request, what is needed, which is the web page, serve that web page, and then it closes the connection. That is what the non-persistent would be. And when the browser gets the content, it's going to display the content or render the content, and then connection is closed. Now, if the web page has number of embedded objects, process is repeated for each of these embedded objects. I want to look at graphically. So there is a client here, you have a server there, it sets up a TCP connection, it takes time to propagate, you get a TCP connection established, and this duration is what is called round trip time, one round trip time. And during this round trip time, client is simply waiting and doing nothing, and that's the time you end up waiting. Earlier time, this used to be few seconds. Now the internet connectivity being faster is probably milliseconds. But this does play a much bigger role looking at the performance. Having set up the TCP connection, now the client will make a request for the URL. Let's say if downloading an image, it makes a request for the image file or a video object or whatever, and then web server would transmit. So there will be a number of TCP packets coming on a single TCP connection, and this indicates the transmit time. The time taken by a web server to transmit all the packets, and when the client gets the entire file at this point in time, it is going to render the image or play the video or something, and that means total time taken is one round trip time for TCP connection, one round trip time to get a content, plus the transmit time, and that's the time taken when you can display the content. This is how basically it works. And this is the case of non-persistent. Non-persistent, now if you have another object to make, you will make another TCP connection, we'll get another handshake, and then do the process. And that is where we'll end up wasting more time. So let's look at the issues between persistent and non-persistent and why persistent gives you better performance. For each URL, you need 2 round trip time before you can get the object. Not even round trip time is one part of it. Each time you set up a connection, the server operating system has to do the extra work, connection setup, and that causes an extra load. And if too many clients trying to connect, set up new connections, server load will go up and performance it will go down. Now typically browser would do parallel connections to get multiple objects to improve the performance, and these parallel connections would be set up. And persistent HTTP, you set up a TCP connection, connection remains on, and so first request will take you 2 round trip time, but all subsequent requests takes you only 1 round trip time, and that way you understand it much better. So I'll explain with an example and show you with the diagrams that how the persistent HTTP gives you better performance, because for all subsequent requests you end up spending only 1 round trip time. So let's look at the following case. Consider a web page has 7 embedded objects. I just took a hypothetical case, and then consider that browser uses 3 parallel connections. Now till it accepts connect to the main and set up 1 connection in one node, and then round trip time between browser and the server when you make a request and get the response by the TCP the web page is 1 second. We assume that the content is small, so there is no transmission time, and browser is very fast in displaying it, so there is no time taken to display the content. Now that being the case, now if you were to make persistent HTTP connection or were to make non-persistent connection, how much time it would take before the browser can display the content. So let's start with first non-persistent, and then we do with persistent connection. Look, we said there's a main web page and which has 7 embedded objects. Now to fetch the main web page, because as a user you type the URL abcd.html or URL xyz whatever. So first browser will make a TCP connection. This is 1 round trip time. On this round trip time, it will ask for the main web page, and now my TCP connection is over because this is non-persistent TCP. Now after getting this page, browser sees the main page has 7 embedded objects, so it has to get all the 7 objects. Now because it is using non-persistent, so for each of the 7 objects, it will make 1 TCP connection. And we said browsers are allowed to make only 3 parallel connections, so it sets up 3 parallel connections TCP. So we look at in terms of round trip time. So we have 2 round trip time where main web page is over, and then we need to get 7 embedded objects. So in third round trip time, it sets up 3 TCP connection, and now this takes 1 round trip time. So in fourth round trip time, it will fetch object 1, object 2, and object 3. And now look, after the objects are over, because it's a non-persistent HTTP, TCP connection would be closed, and for remaining 4 objects is going to set a TCP connection again. And since browser can do only 3 TCP connections, it sets up 3 TCP connections again, makes request for remaining 3 objects is object 4, object 5, and object 6. It has now, again the connection is closed. For 7th object, it sets up a TCP connection and get the object. So total time taken, if you look at, is about 8 round trip time. First to first TCP connection, main web page, then 3 parallel connections, 1 round trip time, 3 embedded objects, again 3 parallel connections, 1 round trip time, 3 objects, and then we have a last object. And this is the way a non-persistent HTTP would work. And for this web page, it will take it. So it doesn't matter whether web page has 7 embedded objects or 8 or 9. Even at a 9 embedded objects, it would set during this 7th round trip time to set up a TCP connection and get all that. So whether it has 7, 8 or 9, it will still do in 8 seconds. Now how does a persistent HTTP would work? First, it has to do a TCP connection. Then it requests for a main web page. So now 2 round trips are over. Now this TCP connection is maintained because it's doing persistent. So on this TCP connection itself, a browser would request for the object 1. But for the other object, is going to set up 2 new TCP connection. So in 3rd round trip time, it will fetch the object 1 and set up 2 more TCP connections because browser is allowed to set up 3 parallel connections. So 3rd round trip time we got object 1. In the 4th round trip time, on connection 1 it will get object 2, and connection 2 get object 3, object 4. Now since we are maintaining TCP connections, it will ask for object 5, 6 and 7. So within 5 round trip time, we got the entire objects. So using persistent HTTP, we got all the 7 embedded objects plus the main web page, whereas non-persistent, we take 8 round trip times, and that means persistent connection certainly gives you better performance because you'll see the web page content in much lesser time, in 5 seconds here versus 8 seconds when you used non-persistent TCP. But again, how many TCP connections one can maintain, that depends on the browser setting. If you are using Windows 10 and the IE 11 or Edge, it probably makes 10 to 14 parallel connections. Chrome browser makes about 8. Firefox by default makes about 10. Firefox makes about 6. So if you make too many parallel connections, that also will hamper the performance because server can't do. If you maintain only one, then it will single object to fetch, it will take you more time. Now as an exercise, if browser were to do only 2 persistent TCP connections, how much time it would take? Can you quickly work out? This I have given you for the case for 3 parallel connections, assuming browser allowed to make only 2 parallel persistent connections, then how much time browser would take to display the web page? Can you quickly work out and give me the answer? Anyone like to give? How long it will take? If I'm allowed to do only 2, you see in the 3rd RTT I got object 1, I set up only 1 TCP connection, this would not be maintained. Then 4th RTT I'll do object 2 and object 3. 5th RTT I'll make object 4 and object 5. 6th RTT I'll make object 6 and object 7. So it will take me 6 round trip times, and that way number of parallel connections make the performance certainly better. Now let's say I made a persistent connection and my connection is on, I'm done displaying web page. Now I'm not making any more request, but my TCP connection is on. If TCP connection is on, a web server is serving many clients, and keeping the connection on for all the clients is going to consume all the resources. So there is no point keeping a connection idle forever, even though client would like to. So typically browser has some configurations which basically says first whether to allow TCP persistent connections on or not. So Apache configuration setup is keep alive on. This indicates that web server support persistent connections. Then say keep alive timeout. That means on this TCP connection, if no new request comes within this time, for example 50 here, if no new request comes in 50 seconds, then server would close the connection. For safety reasons, a server doesn't want to keep using same connection forever because some client may misuse it. So it may still keep a limit on a given TCP connection how many web requests can be made, and that is what is called max keep alive request. So if you install an Apache, download and install Apache, you can basically go to Linux or you can go to apache.org, download HTTP, install it, configure it, and that will be useful to you when you do any web development. For the Linux machine, you can basically do the following. So if it's a Linux machine like this, you can say sudo apt install Apache 2 and it will start installing Apache and then you can work with it. So I'll show you the configuration for Apache. I already installed it onto my machine. So let me show that the configuration file that happens in you say keep alive on. That means this web server supports persistent connections. Max keep alive request is 100. That means on one TCP connection, it will permit only 100 requests, and after that, connection would be closed. And keep alive time are typically 5 seconds because server resources are premier and there's no point wasting those resources. If a web server does not see any request within 5 seconds, it will close the connections. Now, if you want to study the impact of the number of parallel connections, Firefox allows you to configure how many parallel connections you want to make. Whereas in the Chrome and IE is kind of hard coded and fixed, you can't change it. So you want to play with it, launch Firefox, go to about config. So let me go to Firefox. I can say about. It will give you that you're changing tuning parameters, risk, but proceed. Search for persistent. And you see here network.http.max persistent connection per server is 1. By default, if I were to default it, by default it is 6. I can edit it and let's say I make it 1. That means it will keep only one persistent connection and fetch the web page. Now see, when I fetch it, only keep only one, and I have a web page which has number of 10 objects in it, images, and you see with this, it will get one page at a time. So let me accept on my own website. Okay, this is coming from the cache. Oh, I didn't save it, so now it's done. So let me refresh it now. You see, getting one image at a time because I have only one parallel. I set my configuration to be 1. I edit it, make it let's say 4, and then I refresh it. You will see. Are you able to see my screen and the images? Hello? Anyone?
Yes, sir.
Yeah, okay. So if I refresh it,
So,
you see,
so will you
yeah.
when you put 1 and all of that,
Mhm.
will this happen to all the sites you check or only your particular
No,
site?
any site. In fact, this is what you should do. Go to Firefox, access a college website, make the connection, personal connection to be 1, and you see it will make much worse performance. So right now, let me make it 1, okay?
Okay.
Let's access the college website.
So when you change this, it is going to happen only to your computer.
No, no, only to this browser, Firefox browser. Only
Will it
Firefox browser
refresh
allows
like
to
once you
configure.
close it?
IE, Safari, Chrome, they have hard-coded values. They don't allow you to change it.
Oh, so when you like shut the system down and you refresh it, like switch it on again, will it come back to
No,
the
you can always
original
change it.
state or
Once you save it, it's saved. You have to go and edit and change, restore it back. You can restore it, come back to 6.
oh, but
Okay?
what is the necessity of this, sir?
Because more parallel connections, you get better performance. Because you're, see, if you look at a college web page, let's look at the college web page, okay? Let me keep it normal. And let me also do what is called as developer tools. Sorry. Go to web developer, click on the network. Okay. And now let's say I go to ksit.edu.in. If you look at, you see how many connections are being maintained. About main web page contains about 136 or 137 requests. Can you see that's going to 138 and even more? If you
Yeah,
were to
got it.
maintain only one persistent connection, then each of the requests will come one at a time, and the way you take a difference would be very, very poor. When you make multiple parallel connections, you'll get objects in parallel and you get a better performance. And depending on the network speed, server, previously when HTTP started, they recommended 2. As network speed improved, it used to be 4. Now Firefox is 6. Now network speed is much higher. So if you take Windows 10, it makes 10 to 14 parallel connections to get a faster response. If you make it 1,
Oh,
you'll see a very, very poor response. When you make it 6, you'll see a better response. And that's the purpose of parallel connection. And if browser were to do what is called non-persistent, then it will set up a TCP connection every time, and that will take you double the time. And that's the reason persistent connection is recommended. Any questions further?
no, sir, thank you.
So I recommend you to understand the impact of persistent connections, because Firefox is the only one that allows you to configure, play with it, go to different website and see how the behavior is. I've given you my page so that you can basically understand how things work. You can actually see how many connections are maintained. You can launch Wireshark as a tool. I would say go to Wireshark site, install Wireshark, and it can tell you. So let me close this. This doesn't really matter. Download it. This is very, very useful tool to study and understand networks. I'll probably record a video. I will not take a class. I thought I'll do a tutorial, but given the times, I can't. I'll probably record a video and share how to use Wireshark, how to use other tools,
Yes.
and that tells you how you can analyze it. So you can run Wireshark, look at the connections. So let's say, let me launch Wireshark for me. You can actually see what is being happened, what content is being sent, what is being received. You can see each and everything that happens onto the network. I don't know whether Wireshark started or, yeah, no, let me start Wireshark. Sorry, the WhatsApp, not Wireshark. Yeah. Or it is going to, Windows application is going to kill me, so let me not. So this Wireshark, You select an interface, Wi-Fi or Ethernet, whatever, and you specify a host filter, otherwise you got too much traffic. So let's say I do my own website. You'll see a sign coming green means a filter is right. And I select it. Now whenever I access my site, you'll basically see requests coming up. And now you can go to I can stop the capture. You can say statistics, conversations. It tells you the number of TCP connections being maintained that have been maintained in the past, and you can look at all those. You can also look at initially you can make like this is the main web URL, this is the page we found, and so CN is basically TCP handshake connections. I'm getting image 1, image 2. You can see then image and see this connection being maintained 1, 2, 3 is trying to maintain a connection 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. And that is what it does. So it maintains different connections. Look at that, and then you probably be much better off. So play with WhatsApp, you understand it much better, and you can see, and even you can actually look at, in this case, let's say right click, follow TCP, and you actually see what the actual web content is. Whole URL on this given TCP connection, one request, second request, and only two requests on this connection. Or you can see more other requests. You can plan it out and look at it. So download it, read the tutorial, understand it. You'll probably be much better off. WhatsApp is a must for those people who want to understand network. So let me come back. So assuming you understood it, you change it, observe it and see how things really work out. NC is another tool which you can use to communicate without having a browser on command line. Again, I'll probably give you a video recording and then you can probably play with it and see how to use it. NC is again you can download on Windows, install it, but on Mac and Linux is available. So I would prefer if you want to play with networking, if you have Windows machine, using VirtualBox or using a VMware, install Ubuntu, and then you can do a lot of things. The command line understand how the networking really works out. I'll skip this NC part and I'll probably go to some other questions. To summarize what we did, we said connections, which basically indicate connection header is keep alive on, and that means we maintain the connection. So you look at, let's look at the keep alive on even. Let me go to the Firefox here. So I look at my header here. Let me try to. So you can see connection keep alive. That means connection is on. And that if you look at this server, it says keep alive, time it is 2. That means if you don't make a request in 2 seconds, connection will close. And max means on this request, maximum 100 requests would be served. So if I keep refreshing it, you will see the max number will keep going down again and again. If I were to refresh, you'll probably see the number going down. Request header, you see max become 96. And moment it becomes 0. So each time you serve the request, it tells you how many more are pending and then close the connection. And that's the way connection keep alive works. So I suggest to play with it, set it up, look at it both. There is no way to, you want to do non-persistent connection, install Apache, and in the Apache, make keep alive off. Then it will be non-persistent connection. Then you can see a performance. Locally, you may not see a difference, but on real website, you see a difference. So every website today support persistent connections to give you better performance. Just to work out few exercises, let's look at the question. Consider two users, U1 and U2. User has configured browser to use non-persistent connection, but uses 4 parallel connections. User 2 uses 2 parallel connections, but persistent. User 1 has a web page having 10 embedded objects. User 2 having a web page using 9 embedded objects. Consider that round trip time is 1.5 seconds. Can you work out which follower will see the web page first? Browser will show the web page when every content is available. So you have to draw the timeline diagrams, make TCP connections, fetch the objects, and then see which one will give you better response. So as exercise, you try doing it, and we don't have too much time to do on the fly, but I suggest you try doing it, and then you understand. If you don't have, then I can explain you in the subsequent lectures. Another exercise, when I talk about persistent connection, it is always for the website. Even two websites may belong to the same IP address, hosted by the same web server, but when it's a persistent connection, it is always for the website name. So let's say main website has embedded objects with different site name. And that means for each different site, it's going to set up one new TCP connection. If there's only one embedded object from each website, then it doesn't really matter whether it is a persistent, non-persistent, because you're fetching one object. For the first object, you always need to set up a TCP connection. Without that, you cannot live it. So first object will take same time. So persistent connection helps you in subsequent fetching of the objects. And that is where it will make a big difference. But if only one object, then it doesn't make a difference. My last question is that web server supports HTTP 1.1, which is persistent, but my browser supports only 1.0, which is non-persistent. Now, can you maintain the persistent connection? Even though server want to maintain persistent connection, browser doesn't support it, so it won't work. Or other way out, if web server doesn't support persistent connection, then it won't support it, and that's what you can basically do. So I'll recommend that you install Apache, play with it, play with the configuration file. As I said in the Apache, if I were to make keep alive off and restart Apache, then it will not do persistent connection, and every time browser has to set up new TCP connection. So that way should do exercise, spend time with it, and when I give you assignments, some assignments would be based on this, and that's what would be helpful to you. So let me undo it. So that's all I have for today. If you have any questions, feel free. Otherwise, work out the exercises, especially this one, and do your own and see how does it work out. And then you'll probably be much better off. If any question, please feel free to ask. Otherwise, we'll close. And next lecture, we'll look at caching and cookies. And that the last topic would be on HTTP protocol. If no questions, then let's stop and we can disconnect. If you still have questions, you can send me an email and I'll try to answer you in the next class. Thank you.
Thank you.